I just wanted to add a little addendum. I skipped over this slide very quickly, and I just think it's worth it if I take a quick look. So we have this website here, which is the United States Geological Survey, and it says Understanding Plate Motions. And I just would like to run through quickly. We have the divergent boundaries, and the example of that here that they give is Iceland, which is very volcanic, and the Eurasian plate separating from the North American plate. And they've got different links that you can look at that bring you to other images showing how the in this case lava is spouting from eruptive fissures during the 1980 eruption of the Krafla volcano. And so it's a good site. I would recommend it. This one is very interesting. East Africa is separating, diverging, and there's a whole bunch of active volcanoes along the rifting, and you can see them here, the red triangles, and this is areas where plates are separating, and that releases volcanic material, in this case lava, up towards the surface, and it focuses it in different locations. And this is similar to what happened when, again, I'll show you a video of the Palisades that I took actually today, and the diabase that extruded into existing rock. So moving back here, convergent boundaries, these now we're coming together. Here we have the lithosphere subducting underneath, so ocean crust, basaltic crust, subducting, converging with continental crust, granitic crust, and being pulled down by this convection in the asthenosphere and mantle. And behind the ocean land boundary, you get volcanic activity. And this is what you see in the Pacific Northwest with Mount Baker, Mount Rainier, Mount Adams, Mount St. Helens, Mount Hood, going from north to south. This is the zone away from where the ocean plate is subducting under the continental plate and creating volcanism on the land behind. Again, the famous Ring of Fire. This is zone of convergence. Let's just take a quick look at the Nazca South American plate. So here you get lots of volcanic activity, and then you get these rising mountains. The Andes are very tall, and it says here's the convergence of the Nazca and South American plates is deformed and pushed up limestone strata to form towering peaks, as seen here in the Pachapaqui mining area of Peru. And again, limestone well, thousands of feet above the ocean basin where it may have formed millions of years ago. Here's continental convergence, which I showed you a slide of in some other slideshow. I think metamorphic rock, this would be the zone of metamorphism, right? Regional metamorphism. And this is part of the story, or is the story, of the Himalaya Mountains, with the Indian South Asian plate colliding with the Eurasian plate, and this folded belt of now the world's tallest mountains forming. And this is a little diagram before and now after, as the plates collide, riding under, pushing up rock, which becomes a rising Himalaya and rising Tibetan plateau, but of different rocks. This is the South Asian rocks, and these would be your Eurasian. Transform boundary, this is very important in the United States because from San Francisco down to Los Angeles and further south we have always the threat of a major earthquake, and that is because the plates are moving in opposite directions laterally in relation to each other, and when occasionally they slip, they release energy which shakes the earth and causes damage if the shaking is significant enough. So you might want to look at this website. I'm going to leave it there, and I'm going to actually leave it on this picture and say goodbye. I just wanted to review the three major types of plate boundaries with a couple more images.